Okay, good afternoon, and thank you again for your time. It's always a pleasure to present here at Lubgrax again. This is really a continuation of the presentation I gave this morning. So this will just look at another aspect, which is greases. First, I will talk a little bit again about the global base oil pool and what is really happening again in Europe and globally. We'll talk about Group 1 replacement strategies, and then I'll focus more on point depressant expression, and then looking at the grease production. So, as you're all very familiar with the various API groups, really born out of the automotive industry, focusing primarily on the viscosity index, sulfur, and saturates. So even though naphthenic oils are in group 5, which seems very far away from paraphenic groups 1, 2, and 3, but from a chemical perspective, they overlap quite a lot, and they're pretty close to each other. So I don't like to focus too much on API classifications of base oils. You're probably well familiar with all these numbers, but as you know, there's a big shift from group 1 to group 3 and 2. And you can see that I would say, over the last 8 years, specifically looking at the mineral oil pool, the shift has been probably significant, considering how slowly things move in the base oil market. Coupled with that is the whole wave, or I heard someone say yesterday, tsunami of group 2 and 3 coming onto the market. We see that this capacity is going to continue increasing over the next coming years. Just a scan from our perspective, we estimate that there's around 48 various projects that are apparently under construction or in the planning stages of Group 2 and Group 3 development. We think that this will obviously create more of an oversupply situation in the market. And the demand growth rate will also only determine the extent of the oversupply. So if the demand rate is slow, then the oversupply is going to be even bigger. So the new group 2 and 3 capacity, I think, has created quite a complex and dynamic competition scenario in the automotive industry. I think that this overcapacity and availability in the market, especially during 2014, has resulted in people moving much faster into new formulations and new Group 2 and Group 3 systems. So I think that this move has also been driven from a supply perspective as well. This obviously has further eroded the market share of Group 1 oils. So the additional disadvantages for Group 1 in the market. So several orders of considerations will be at play. Firstly, I would say that 90% of all the oil refiners also have an in-house lubricant business. And in their businesses, this usually represents only 1% of the output of a typical oil refinery. So usually the fate of a base oil will mostly depend on the operation and the financial viability and the refining economics of the great mothership, which is the great oil refinery, which is obviously more focused on fuel production and being driven by environmental and clean fuels and low sulfur diesel legislation and so on. So there are also other factors that are going to come into play: the market demand, crude flexibility, and the fit of a base oil plant into fuel strategies will also play a role. So this is why Group 1, large refineries are shutting down their Group 1 trains, or the Group 1, they're looking at the refinery economics, and their focus is on upgrading other parts of the business, or Group 1 production tends to be an older type of technology, so they need to sort of upgrade these plants. People would rather focus on maybe shutting it down or reducing capacity, or building a Group 2 or Group 3 production. So because Group 1 plants are older, they have a much higher costs compared to Group 2 and Group 3 production, because these will be newer. And then they also give a refiner a much lower crude flexibility. So the ability to source different types of crude for your refinery, or maybe be able to buy a cheaper crude or something, you would be restrained by what would then be just this 1% of your business. So with this sort of growing market and a good fit for fuel strategies and crude flexibility, makes Group 2 and Group 3 plants a much better position and a much better fit than Group 1. So obviously Group 1 plants are going to close. And I think not only that, but other plants will be forced to probably reduce their operating capacities, or they'll try to contain inventories. Also bearing in mind that those large oil companies who have an in-house lubricant business might also produce only for their own consumption and not put out Group 1 into the market. Right, so this morning I put up some figures just looking at the European market. But here I've included other countries as well. And this is really just our own personal list. As NYNAS is a global company, and we have offices in about 30 different countries. We just like to keep track of what's happening. And as you can see, that of a very short space of time, I think this tallies up to a nameplate capacity of like 2.3 million tons gone from the market. And if we think that this is probably just the beginning, I think for the market to stabilize or get some type of balance, this probably represents about 10 to 15% of what still needs to come. So more Group 1 plants will close down, and over the coming years, and not only in Europe, but probably globally as well. So, I know, looking at Group 1 and where these oils are used, they are primarily used in industrial lubricants. I know the numbers are 2 years old, but I think we can get a gist of the picture. So about 50% will be using industrial lubricants in the formulations, and then some naphthenics, Group 3, and some PAOs, Group 2. So how is the market going to move away from Group 1? So for those very traditional industrial applications, they will really only have a few options. The first thing will be obviously to convert to Group 2 or Group 3, where possible in the formulations. The second option is probably to use naphthenic oils, where possible again. And the third option could be a blend of naphthenic and paraffinic molecules to meet this gap in the market. And that is really exactly how we have placed our new product range at NYNAS. So at the bottom, I have listed solvency, and on the other axis is the viscosity. So the big gray bubble in the middle at the back is representative of Group 1. So if that sort of disappears from the market, then you have a less viscosity and solvency available, whereas naphthenics can offer much more solvency and viscosity. And on the other end, you have group 2s and group 3s with this limited viscosity and solvency offer. So a blend of these molecules could be a good fit for the market or the missing big grey bubble in the graph. Right, I did introduce the NYNAS range this morning, so I won't spend too much time on it, but just to say that when we started creating these products, we focused primarily on the viscosity and the aniline point, so we matched this quite up with the existing solvent-neutral oils. You will, of course, get the benefit of good low-temperature performance. Compared to group 1, you will have the challenge of maybe a slightly lower viscosity index, and you might also have a challenge of a slightly lower flash point. However, this is not always required in all applications. And then in response to the market requesting high viscosity products anyway, we then created some further products then focusing on meeting the VI. So even though the first set of NYNAS products had a viscosity like within the 80 range, the market was still asking for a viscosity index of 95 or higher. So, right, I wanted to highlight something that we discovered quite interestingly enough, is that typically when one is using paraffinic oils and formulating, you would include a pore point depressant, or at least in those regions where it's required. So we wanted to just understand how these new NYNAS products would respond to that. So we used a very low dosage. And on the extreme right, yeah, you're right. On the extreme right, you can see the solvent neutral as a reference, and then the rest of the NYNAS products. And we see an excellent response to a pore point depressant, even at a very, very low dosage. So I think the interesting thing here is that the naphthenic molecules are actually acting as a natural pore point depressant when mixed with certain group 2 or group 3 molecules. So it could be, because they are cyclical-like in structure, so they could be preventing a crystallization of the wax-like molecules and delaying that process. That was interesting, and we'll touch back on this when we get into the greases. So that was just, those are the two of similar viscosities. Great. So I specifically just took 2 grains of the new products and tried to make some greases with them. These were the base oils used. So in the first column, I have the solvent neutral, the SN 500, and the 2 NYNAS range products at 100 and 120 centistokes. There you see that you get the benefits of a good pore point. There is a slightly lower viscosity index, and the flash points are also probably maybe a bit lower than what you might expect. At our Global Technology Center, which is where I am based in NYNAS in Sweden, we have a small grease laboratory. We do not sell greases, but we are always interested in understanding how our oils are performing in various applications. So we have a pilot scale, and we have had this since 2011, so we've gotten, I think, a good understanding of how to make grease and also how the oils are behaving. So they took these 2 samples. We made some greases. We use a simple lithium conventional greases and 12-hydroxystearate acid. We use the same base oil throughout the production process. We targeted an NLGI grade 2, and these were just base greases without any additives. Great, so looking at the some of the results, as I mentioned, we targeted an NLGI grade 2, so that the pen after 60 strokes are roughly in the 280 zone. If you look at the penetration after 10,000 strokes representing the mechanical stability, they all kind of panned out at the 300 mark. The difference in pens indicating still sort of on what we would call on spec. The dropping point, of course, just a reflection of the thickness system. Pretty much similar copper corrosion. With the grease, the oils of same viscosity, the solvent neutral and the NYNAS base, we see a very similar thickener content. The more thickness required for the higher viscosity, we think that's probably related to the lack of solvency, or maybe we need to tweak our pilot scale process a little bit. Right, so because we saw this interesting thing with the pour point behavior, we were curious to see how the low temperature behavior of the grease was going to be impacted by this. So there's a test called the flow pressure. Maybe most of you are familiar with it. So you just take a small bit of grease and you have it in a conical nozzle and you apply a pressure as the temperature is dropped significantly to very low ranges, and you note the pressure at which the grease begins to move. So this is a reflection of the pumpability or the flowability of a grease at a very low temperature. So we've plotted it over a temperature scale. So grease A is the group 1, and grease B and C are the new sort of NYNAS-based products. What's interesting to note is that there's very little difference in the pour points of the oil. But as a grease, there's a significant difference in the performance at extremely low temperatures. This is important for sort of Nordic or Arctic conditions. Here, it's probably the wax crystallization starting at much earlier stage than perhaps anticipated, or perhaps earlier than the pour point would indicate. Great, so we also wanted to look at some rheology to understand exactly the flowability or the flow dynamics of these greases. We use quite simple setup, plate-on-plate geometries. We did some strain sweeps, some temperature sweeps, and so on. So just a few left. Right, so first we tried to it's maybe a bit difficult to see with the different colors, but here we have the storage modulus and the complex modulus. So it's because grease is a viscoelastic kind of material, so this represents the viscous part, which is usually the top curve, and the elastic part, which would be the sort of lower curve on each branch, on each graph. Then we have this viscoelastic region, so you want that to be as long as possible, and you want, as your grease is sheared, what you're looking for is that you expect some softening, but you don't expect that much softening, so you want it to be stable or hold out as long as possible. I think in general, I would say the results were pretty similar. I would say that grease A, which was the solvent neutral, was slightly softened much quicker. I would say that the grease probably with the higher thickener content, probably that had a bigger role to play in these results. So a similar kind of flowability, I would say. Right, so because one of the greases, one of the oils in this study had a slightly lower viscosity index, I wanted to look at low temperature and high temperature rheology. So here, again, we have these pour points. This is a low temperature sweep. You see that the NYNAS greases are pretty stable at low temperature, and whereas the group 1 grease requires much more strain or pressure to move. Right, and then this is now the higher temperature sweep. Again, pretty similar. We see that grease B, which is the NYBase 500, performing slightly worse, I would say, than the other two greases. I think this is because that particular oil had a lower viscosity index, so I think we're seeing more of the temperature impacts. The other two had VIs of over 96, whereas that black graph was about 79. Great. So really, in summary, right, the evolution of the base oil pool obviously emphasizes the need for new base oil formulations. So the blends to replace these group 1s can be part of the solution, definitely. So we obviously have developed these new products. We see some interesting point present results that we can look into a bit further. And we think that this screening or evaluation study of how these new base oils are performing in a crease application is very, very promising and can definitely be used as an alternative to Group 1. So that was me. Thank you very much for